And today we'll solve interesting and very useful problems which is recent in fashion from complex numbers. It's useful both for JEE Mains, Advanced and for other competitive examination as well. I've taken more challenging questions, so which will be primarily focusing on tough problems of JEE Mains as well as Advanced. Good evening all of you, and today we are going to solve very interesting as well as useful problem, and we'll see how basic IIT is going to help you to analyze complex numbers problems. Okay, so here is the first question. We have a set S which contains all those complex numbers z such that mod 2z is greater than or equal to 1 plus z square. We have to draw a diagram for this, which means basically locus of z. So let's start in a usual STU typed way. If I put z as x plus I1, that simply gives the given expression becomes 2z, 2 mod z, basically 2 root of x square plus y square is greater than or equal to 1 plus x plus iy whole square, which evaluates to this. You can see it's 1 plus x square minus y square plus 2y xy magnitude. So it will be this square plus 4x square y square. So it's better if we can square both terms, and we got 4 of x square y square is greater than or equal to 1 plus x square minus y square whole square plus 4x square y square. Now with a little bit patience we can evaluate these expressions. So it's a plus b plus c square, so a square b square c square minus 2y square plus 2x square y square plus 4x square y square. So if we'll keep everything on one side, we can see we are getting x4 plus y4 plus 1 minus 2x square is 2y square plus 2x square y square minus 4y square is less than equals 0. Now by looking at this equation we are getting some feel, right? So maybe like this feels very clumsy, so can we decode information out of this? Let's give it a try. x4 is x square square, right? y4 is y square square, and 1 feels like 1 square. This is like 2 times of x square and 1. 2y square is 2 times of y square and 1, and 2x square y square is 2 times of this. So it automatically from x4 till this term it's a plus b plus c whole square, right? So this entire term I can club, and simply it can be written as x square plus y square minus 1 whole square, and the other guy is nothing but minus 2y whole square less than equal to. That's a good news, because now we can use a plus b a minus b. So this into x square plus y square minus 1 plus 2y is less than equals 0. Right? So what does it mean? Now clearly you can see this both looks like a circle expression, right? So this inequality will be satisfied if either this is positive, this is negative, or this is negative, this is positive. So they should have opposite sign. This both expression must have opposite sign. Of course, like equality can be achieved anywhere or at both of them simultaneously. Okay, so let's try to solve the first constant if this is positive and this is negative, right? So before we analyze this, it's better we can see at what value x and y become 0, and at what value the other expression will become 0. So in order to solve the inequality, we always solve first line of control, the boundary line, and then we can see whether it's in above region or below region, right? So for this equals 0, the expression is, let's say, this equals 0. So what does this both equation represent? Clearly you can see this is a circle, because this I can make perfect square. X square plus y minus 1 whole square equals 2. The other guy is x square plus y plus 1 whole square equals 2. So let's try plotting both of them on a single xy coordinate. How does it looks? So first circle is clearly centered at 0, 1, radius root 2. Okay, so this is 0, 1. Since it's root 2, so at least something like this, right? Second circle is at 0, minus 1 and radius root 2. So this is going to be at 0, minus 1 by symmetricity and radius root 2. So they'll intersect exactly on the x-axis, because you can see if we'll take s1 minus s2, if we subtract this both equation, So that is nothing but S1 minus S2 is a line which is basically x-axis, right? Moreover, from symmetricity you can see is the limit at these 2 points. Now what exactly is the graph? So any point inside the circle. So maybe the first expression when it is positive and the second expression is negative. What does it mean? First expression is positive means you are outside the first circle, and second expression negative means inside the first circle. So if I'll take this positive and this negative, of course greater than equal to 0 is allowed. So what we are getting this is this region, right? So this is the region that I'll be getting out of this condition. If I'll take other condition, less than equal to 0 and greater than equal to 0, then of course the answer will get is the other region. Why? Region is very obvious, because now I want answer to be completely inside the first graph, but it should be away from the second. So you should be inside the first circle. If I call upper circle as the first one and lower circle as second one, but it should be outside the second circle, so you get this region. So this is a very beautiful answer, and you see locus consists of the shaded part here. So we'll not have any point in the intersection of these two circles, right? So if I call this circle S1 and this circle S2, locus is basically S1 union S2 minus that intersection point, right? Everything except this. So any point in this region, the shaded region, will work. And this is a very beautiful problem, because clearly you can see many different problems can be asked from here. Like suppose if S denotes this region, they might ask you what will be the maximum value of maybe Z minus 3, right? Or what is the range of this? So what is the range of Z minus 3? So this point is clearly 1, 0, right? So 3 is here. Now Z can move anywhere in this region except this white region. So maximum, so clearly minimum you will get, you have to take either this length or this length. Okay, so among these two lengths, whichever will be minimum will give the minimum value of mod Z minus 3. Mod Z minus 3 means distance of 3 from any Z, since Z can dance in any of this region. Similarly, maximum value, either it will come here or maybe diametrically opposite. Okay, so you have to check just corner point. Of course, from diagram you can say the maximum value will come diagrammatically opposite case. Okay, even it can come here as well. So maximum can come either at this location or this location or this location. So you can just find these two and you can check like whichever is giving maximum. Here no need to find this, because if you join this is 90 degrees, so this hypotenuse will be maximum. Okay, so maximum will definitely be this point. This will give maximum value. Minimum maybe the shortest distance will get. Similarly, they could tell you like what is the range of argument of Z minus 3 also. So you know, like argument of Z minus 3 is the angle that is making. So clearly the maximum angle that it might make is 180 degree when you are here. So range is basically between these two tangential cases. So this is special theta naught, maybe this is by default minus theta naught. So once you know this radius r and this distance is known, you can find theta naught value, right? So even the range of this argument can be found. So many problems can be asked. Once you know the geometrical implications of this, it can be solved. Now some of you might be wondering like, okay, well, once you saw the solution, you develop the patience like it can be done. But in the beginning, it was very pathetic to start with. No, it feels like you will not have enough motivation to start with x plus iy method to find the locus here, because maybe after second step, many will give up. So I'll urge you to solve these questions in a more happier way if you want, using polar form. So if we'll take x equals r e to the power I theta, which means r cos theta plus ir sin theta. You plug all these informations here, at last you'll get an equation. In that equation, simply you can put x equals r cos theta and y equals r sin theta. And then you'll see very nicely you'll get the same locus. Okay, you'll get the same locus, maybe not with this manipulation, but simpler manipulation. So that is left. There is no, complex number involved in this. Of course, you can try solving this problem by some other basic method, like by analyzing an equation, a cubic equation having these three as roots, that root number 1. The other way probably can be just simple manipulation. Maybe you can multiply with sine cos pi by 7 to create sine 2 pi by 7. And then you can see like this can be converted into maybe 3 pi by 7. So it's kind of chain reaction. Usually that's the usual way. I'll not go with other ways of solving here. let's try to directly attack this problem with complex number. So cos pi by 7 is giving enough motivation to think of a complex number, cos pi by 7 plus I sin pi by 7. So let's call it z. So if I write z is this, so clearly z bar, which is 1 by z, can be written as cos pi by 7 minus I sin pi by 7. Since we know mod z is 1 in this case, so z bar is nothing but 1 by z, because z bar is mod z square. Hence, we can clearly see z plus 1 by z is nothing but 2 cos pi by 7, because z bar is 1 by z in this case, since mod z is 1. Right, so cos pi by 7 can be written as z plus 1 by 8, which is z square plus 1 by 2z. Similarly, what is cos 4 pi by 7? Okay, now 4 pi by 7 can be written as just 3 pi by 7, right? Because cos of pi minus pi by 7, so cos 3 pi by 7. Similarly, 5 pi by 7 can be written as cos 2 pi by 7. Of course, it will give, you know, like minus sign, but minus will be plus. So overall, this expression is cos 4 pi by 7 is nothing but cos pi minus 3 pi by 7, and cos pi minus theta is minus cos theta. So this quantity is minus of this. Similarly, cos pi by 7 minus of this. Anyway, minus plus. So equivalently, the question reduced to cos 5 by 7, cos 2 pi by 7, and cos 3 pi by 7. And once I notice cos pi by 7 is that exactly in the same way, instead of pi by 7 you put 2 pi by 7. So this time instead of z you will have z square, right? So if I square it, it will give you e to the power 2I pi by 7. And same you can do for the second x. So that will give you z4 plus 1 by 2z square. And what about cos 3 pi by 7? Now we have to do z cube, so that will give z6 plus 1 by 2z cube. Now all that I need to do is just to multiply this 3 expression, right? It might feel clumsy in the first go, but let's see how beautifully the answer reincarnates. So if I multiply these 3 values, that's the question. So we'll get z square plus 1 to z4 plus 1 to z6 plus 1 over, we have 8 z6, right? 1 plus 2 plus 3. And this little bit now we can expand. So we have z12 plus z10 plus z8. Just I'm multiplying. 2z6 will come. We have z4 plus z square and plus 1. You can just check the multiplication. 8z6. Now what is the speciality of z? Since I've defined z to be e to the power I pi by 7, which is cos pi by 7 plus I sin pi. So z to the power 7 is e to the power I pi, which means cos pi plus I sin pi. Sin pi is 0, so minus 1. So z to the power 7 is minus 1. So that just I'll use repeatedly. If z to the power 7 is minus 1, so this quantity will be minus z to the power 5. Because z to the power 7 into z to the power 5. This will become minus z cube. This will become minus, yes, z6. Let's keep z6. z4 is z4. Z square. Okay, so this quantity we can write, in fact, now the given quantity can be written as minus z5 minus z cube minus z plus z6 plus z4 plus z square plus 1 and plus z6. Okay, so 2z6 I'm writing z6 and z6. There is a reason why I wrote like this, because now we can clearly see, like we can write this in a very nice fashion. What is that nice fashion? You can observe the powers of, so z2, then 3, 4, 5, 6. Okay, and we have here power 1. So you see alternate plus and minus sign is coming, which means this can be written as z6 minus z5 plus z4 minus z cube plus z square minus z plus 1 plus z6 divided by 8z6. Now beginning from this quantity to here, we have a GP. So you can see just a standard GP with first term 1 and common ratio minus z. So we have a GP with first term 1 and common ratio minus z. So that's nothing but z7 plus 1 by z plus 1 plus z6 by 8z6. Now z7 is minus 1, so this goes, z6 and z6 goes, and we have 1 by 8 is the answer. So you see how beautifully we solved a problem of trigonometry just using complex numbers. What I have done here is nothing more than using Euler's formula and representation of complex number. Okay, so I'm giving an exercise for you. You can try even. So here is an exercise for you. Exactly in the same way, you can try this question, which usually takes high level of manipulations if you directly do by trigonometric equations. Of course, it can be done, but it will take high level of manipulation. Using complex numbers, similarly, you write cos pi by 7 as z square plus 1 by 2z and do all the calculations. You'll get very interestingly this time that you can check by yourself. So this time you'll get very interestingly z cube by 2z cube, and things will get cancelled and you'll get half as the answer. So all of you can try this. It will be nice to apply those concepts. Let's move to the next problem. X if z plus 1 by z equals 1. Usually these problems in a standard textbook is solved using triangle inequality, but there is a problem with triangle inequality, especially when you are solving this non-linear kind of problem. The problem is you are not quite sure like why the equality should be achieved. So I'll give you a more general and more formal solution first before you go and see some trick of it. So here we go. Usually the question is posed as mod z is given and you have to find mod z plus 1 by z maximum minimum. So that's straightforward, you can do with triangle. This is also reverse triangle inequality, but I'm going to do something else, right? Z if I start with a random complex number r e to the power I theta. So clearly you can see z plus 1 by z whole square I can calculate in order to find its magnitude. So that will be nothing but r e to the power I theta plus 1 by r e to the power minus I theta into its conjugate. So it's r e to the power minus I theta plus 1 by r e to the power I theta. The conjugate of this will be minus and conjugate of this is minus, right? Because z bar is 1 by z here, since mod z is 1. Sorry, because z bar will be mod z square by z, so it will be r square by z, and z is already, let's say, r e to the power I theta, so it will be r e to the power minus I theta. Once you multiply, you see many things get kicked off, so that whole square becomes r square plus 1 by r square plus 2 cos 2 theta. Okay, so basically we need to find mod z max if this value is given 1. So since this is 1, so this quantity will be 1. So now we have a relation in r and theta. So we know how these complex number r and theta are related if z plus 1 by z has to be 1. Okay, so far so good. What we can do is we can directly solve for r because it's a quadratic in r square. So r square plus, what we can do is we can directly solve for r because it's a quadratic in r square, and mod z is nothing but simply r, so we need to find the maximum value of r, right? So this quadratic will straightforward give r square is minus 2 cos 2 theta plus minus, what's plus 1 will become minus b, right? Plus minus root over 2 cos 2 theta minus 1 whole square minus 4 over. So for r square to be maximum, we must have cos 2 pi equals minus 1. Why? The justification is when this is most negative, at its negative end, cos something will dance from minus 1 to 1. Then this entire quantity will be positive. And that added with, if this becomes minus 1, so that will become 9, right? So 9 minus 4 is 5. If this is plus 1, it will be minus root 3, which is anyway imaginary, so you can't take it 1. Okay, so cos 2 phi minus 1 is giving this as maximum as well as this as maximum. So both is assisting together. So we know cos 2 phi equals minus 1 will give the maximum value of r. So just you put cos 2 phi maximum. So r max is going to be root over minus 2 into minus 1 plus 1 plus 2 over 2 times, that will become 9 minus 4, right? So which is 5 over 2, and which evaluates to simply root 5 plus 1 by 2. So this was very interesting. You see, like, this is the maximum value that we are getting. Now the point is, for what complex number we have achieved the maximum, and 2 phi is minus 1. It means cos 2 phi is minus 1 is cos pi. So at least one of the value we know is pi by 2. So the complex number is, you know, like purely imaginary. The rare condition you got is maximum. Clear? So this was a good question. And you can similarly find the minimum also from this range. Mod z equals 2, and we need to find z minus 1 by z minimum value. So again, method 1 will be, you can directly take z equals to e to the power I theta, right? And then mod will be 2 e to the power I theta minus half e to the power minus I theta, which goes to 2 cos. I'm not writing cos theta as, so it's 2 cos plus 2 I sine minus half cos and plus half I sine, which evaluates to 3 by 2 cos and plus 5 by 2 I sine naught, which is nothing but root over 9 by 4 cos square plus 25 by 4 sine square, and that gives you, you know, like 25 plus 9, 33. Okay, so this can be written as 9 by 4 cos square plus 25 by 4 minus 25 by 4 cos square, which evaluates to 25 by 4, and that quantity is minus 16 by 4, so minus 4 cos square, right? Now of course, when this value cos square will dance from 0 to 1, so at 0 we'll get the maximum value, which is 5 by 2. Okay, so the maximum value of this expression will be 5 by 2, and the minimum value will be when this is 1. So it's 25 by 4 minus 1 root, so that's giving, you know, 9 by 4 root, so which is 3 by 2. So we have minimum value of this expression 3 by 2 and maximum is 5 by 2. Okay, so this minimum is, this entire minimum is 3 by 2. In fact, I could have asked for maximum also, and that's 5 by 2. So the range of this expression is 3 by 2 to 5 by 2. Let's see method 2 of doing this. Like, maybe that will become a first if directly you use triangle inequality here. So mod z minus 1 by z is nothing but mod z square minus 1 by mod z. In this case, mod z is 2, so I can tell it's mod z square minus 1 by 2. Now if I use triangle inequality, so you know a plus b must be greater than or equal to mod a plus mod b. Okay, and a plus b is more than the third side is more than difference of two sides. So this is basically triangle inequality when you represent complex numbers in triangle. So this can be written as, the upper one is two complex numbers, so third side is greater than difference of two sides, so mod z square minus mod 1 by 2. Now we know mod z square is mod z whole square minus 1 by 2, and mod z is 2, so 4 minus 1 3 by 2. So this shows you how to get, you know, like the minimum value of this expression. So this quantity is always more than or equal to 3 by 2. A very settled point here, the micro analysis will be, in some questions if you blindly apply you might get minimum, but you will never be sure like whether minimum is achieved or not. Okay, so whether equality is achieved or not, yes, it is achieved here indeed when a, b and a plus b, right? A, b and a plus b, they are collinear. So for equality of this triangle inequality, they must be collinear. Okay, so in this case you can clearly see it's possible. Like we have z 1 by z and z minus 1 by z. So if all those three vectors represented in complex form is collinear, then the equality will be achieved. So in this case it is achieved. Let me give more intuition to this by giving a third method, which is a bit of geometrical. So let's try to solve this problem geometrically. I'll give you, like the feel of what geometrically it means. So we clearly know mod z equals 2 will represent all points on complex number, which is on a circle, centered at origin and radius 2. Now what does z minus 1 by z represent? So let's say if I take this point, okay, so it's 1. So if z is 1, it will go to 0. So basically this point is being sent to 0 by this expression, right? If I pick up a point, let's say I over here, so let's see where it goes. So I minus 1 by I, that will become I plus I, so which is 2I. So this point goes here. Make sense? Okay, so if I pick up this one minus I, this is minus 1. If I pick up minus 1, it's minus and plus 1, so it's still 0. So that feels crazy, like these points on the extreme, this went to 0. The point here, which is minus I, and this will go to minus 2I. So can you think like what basically is happening to the points z minus 1 by z? Okay, so if I pick up this point, maybe it will go somewhere still, right? So let's say if I pick up a point 1 plus I by root 2, which is actually making 45 degrees. So you can find 1 plus I by root 2 minus 1 by 1 plus I by root 2. In fact, 1 by z is z bar, so it's 1 plus I by root 2 minus 1 minus I by root 2. 1 by root 2 will cancel, so we'll get basically 2I by root 2, so root 2I. So again interesting, like this went to root 2I. Okay, in fact you can see, like if I pick up any point on the circle W, okay, so W minus 1 by W is basically W minus W bar. So if W is in any form, let's say cos theta plus I sin theta form, W bar will be minus cos theta minus I sin theta form. So what this W minus 1 by W is doing, can you clearly see? It's 2I sin theta. It's picking all the points on a circle. It's taking all the points on a circle, and it's making it through on a straight line. It means the circle is being converted into a line segment. The entire line you are getting, right? This entire line segment you are getting. So you pick up this point, it is sent here at origin. You pick up this point, it's sent here at origin. You pick up this guy, it's sent here somewhere. Okay, you pick up this guy, it's sent here. So on and so forth. So basically the circle is being converted into line. And now you can clearly see what is the maximum value of z that you are getting. Okay, so what is the maximum value of z minus 1 by z you are getting? Right? So we got somewhere like, so is there any point for which we'll get, like the maximum value and then mean value? Okay, so if it were, so this I have solved if mod z were 1, right? So you can clearly see the maximum value that you are getting. If the question would have been mod z equal to 1, then the maximum minimum of mod z minus 1 by z. So minimum will be 0. Okay, magnitude, and the maximum magnitude will be root 2. But the question was mod z was 2. Okay, so mod z was 2. You can repeat the same logic and you can see like how it sends another straight line with the values as 3 by 2 and something else. Clear? So I hope, like, clearly I have not done the question for mod z equals 2 here, rather I have done for mod z equal to 1. So I want you to solve it for mod z equal to 2. Similarly, like geometrically you can feel what's happening, how it's being done. So basically it not only shows you this solution, but it also shows for mod z equal to z minus 1 by z, locus is going to be straight line here in this case. What if it were z plus 1 by z? Again, you can think by putting some point and you'll be surprised to see it will be ellipse. Okay, let's move to the next question. So this is a very interesting question. We have mod x plus y by 1 plus x y bar if x and y are complex numbers. Magnitude of a complex number is a. So there is complex number x can be anywhere in a circle with magnitude a. Magnitude of yb is b. Right? So y can be anywhere in other circle. Under this condition, if magnitude of x is a and magnitude of y is b, we have to find the minimum value of x plus y by 1 plus xy bar. So again, how will you start this? So let's, if I call this entire thing as some complex number z, so z square, mod z square is nothing but z bar. So we'll take x plus y. The best way to start a mod problem is to take its square, because this is a way where from real world you go to the world of complex numbers. This is a gap, right? So whenever we have mod question, you take a square and go to multiply, which is conjugate, and half of your problem is solved. Now x y bar will be x bar and y bar is y. If you're going to multiply this, you can easily see x with x will be mod x square, yeah, mod y square. Then we have x y bar plus y x bar, x y bar plus y x bar divided by 1 plus mod x y whole square, because x y bar into x bar y, x bar is mod x square and that's y square, so it's mod x y whole square, we can write, plus again it will be like x y bar into x bar y plus okay, so next will be x y bar plus y x bar. And now we know, is there something special about this? Yes. So if this is u, it's u bar. If this is w, it's w bar. So it's better we can see what is u plus u bar. Clearly is x plus iy plus x minus iy. This is 2x, which you can be written as 2 times real part of u. Right. So using this, I can write this expression as 2 times real part of xy bar or yx bar. It's same thing. This is also same as 2 times real part of u bar. This can be written as 2 times of real part of like xy bar. So the given expression becomes this. Okay, now we know already mod x is a, mod y is b, so this is ab. So we can write the final expression in a cool way: 2 real xy bar by 1 plus ab plus 2 real xy bar. This still you can a little bit manipulate. So if you'll add and subtract 1, because you can see like 2 real part of x bar is common. Okay, so if I want, I can write this in some cool form. So you add like 1 plus ab in numerator and subtract 1 plus ab. So if I'll add 1 plus ab and subtract 1 plus ab, then probably a square plus b square, and 1 minus 1 minus ab is left together, and this quantity till here will cancel this. So that can be written as 1 minus, just I'm doing algebraic manipulation. It's 1 minus a square minus 1 times b square minus 1. You can just club these two, divided by 1 plus mod xy bar whole square, so which is a square b square, and plus 2 real part of xy bar. So now the entire expression, so mod of this, basically we started with mod z square. So mod z square I have converted in terms of a and b, which is constant here, and we have only variable which is xy bar. So in order to find the minimum and maximum value, we have to find minimum and maximum value of this, minimum and max of real part of xy bar. Now what is the restriction on x and y? Okay, there is no restriction. X and y can be any random complex numbers. Just the only restriction is their magnitude of x is a and magnitude of b is Magnitude of x is a and magnitude of y is b. Okay, so let's see. If we have magnitude of x equals a, magnitude of y equals b, what will be the real part of x, y bar range? Okay, if we can find this, we are done. Okay, so can you comment on this? Okay, so x we can simply take as a e to the power some I theta, y let's say e to the power some I phi. Then what is x y bar? Y bar is going to be e to the power minus I phi, right? So x y bar will be a b e ka power I theta minus I phi. So which is a b into e ka power I theta minus phi. And I know it's a b cos theta minus phi plus I sin theta minus phi. So what about real part of this quantity? Real part of this is nothing but AB. So real part of x y bar is AB cos theta minus phi. And hence the maximum and minimum value of that is already known to us. So hence its maximum will be AB and minimum will be minus AB. And that will happen when this is either 1 or minus 1. So you know the phase angle like theta and phi. Okay, if they differ by pi, theta minus pi is pi, will get minimum. And if theta equals phi, both complex numbers are in the same direction, will get maximum. So with this information, where we know the real part of x y bar maximum will be AB now and minimum will be minus AB, we can solve this problem. Okay, so we have cases now. So what I can tell, minimum under the restriction mod x equals a, mod y equals b, mod of x plus y by 1 plus x y bar. Clear? So let's put the value of this. If I'll put this as AB, right? If I'll put this as, let's say, the maximum value, which is AB, so this will become 2AB. So if this is maximum, the entire thing will become minimum, and 1 minus that will become maximum. So mod z square max will be when this quantity is 2AB. Okay, so if we'll put that 2AB, what will get? 1 minus a square minus 1 into b square minus 1 by 1 plus a square b square plus 2ab. So that is 1 plus ab whole square. And this you can simplify, so that's mod z square. So we have 1 plus ab whole square minus a square minus 1 to b square minus 1 by 1 plus ab whole square. This you can write as 1 plus a square b square plus 2ab minus a square b square. I think we'll get plus a square plus b square. We have minus 1 by 1 plus ab whole square. We simply evaluate a square b square gets cancelled, 1 1 gets cancelled. So ऊपर में we have a plus b whole square, down 1 plus ab. This is not a single problem. You see, it's a great problem which reveals huge concepts. So now I know, like mod z square is this in any case, right? So mod z square maximum value is this, because while putting I have kept the maximum value of this AB. Okay, so similarly you put minus AB and you get the minimum. So now we know the maximum value of mod z. So mod z max is gonna be a plus b by 1 plus AB whole square. So we know mod z square maximum is this whole square. So mod z max is going to be this, right? Similarly, we can find the minimum. Okay. Similarly, we can find minimum. So mod z minimum the value that you are getting. Similarly, you can find minimum. So minimum of mod x at A, mod y at B, mod of x plus y by 1 plus x bar y. This will be 1 if at least one of the number is 1. If at least one number is 1. Because you see, if at least one number will be 1, this quantity will simply go. Right? Because if mod of A, if A or B is 1, this quantity will go. Fine. So mod z maximum or mod z minimum, directly you'll get 1. So here mod z minimum will be 1. Now if both of the numbers are greater than or less than 1, under that case the minimum value of this is going to be mod A minus B by 1 minus B. Just you put minus B and you can put all the options. So this is for both A and B, either greater than 1 or less than 1. Now if one of the number among A and B is more than 1 and other is less than 1, so let's say A is more than 1 and B is less than 1, or A is less than 1 and B is more than 1. Under this condition, the minimum value of the same expression we'll get is A plus B by 1 plus A. So we have three beautiful answers. Under this condition, we'll get this answer. If both of them is more than 1 or less than 1 is this answer. And if one of them is 1, the minimum value of this expression will be just 1. So this was a very beautiful problem, and see how fundamentally the only hint for this problem was how from the world of real we are entering into complex using mod z square and z bar. Okay, so I hope you have enjoyed this session. I will come with more challenging problems like this in the upcoming session, which will not only develop your critical thinking